In August 2014, a paper was published in the specialized press that drew little public attention among a barrage of tragic news on street shootings, civil wars, and genocides. This scientific paper explained a feat of the nuclear industry, the distillation for the first time on planet Earth of a nanoscopic quantity of strangelet at Brookhaven's relativistic heavy ion collider. A strangelet is a substance made of liquid quarks, which is the most powerful explosive in the universe. Physicists believe liquid quarks have fueled the Big Bang, as well as other cosmic catastrophes like quasars, the Big Bang of galaxies, supernovas, the Big Bang of stars, and ice-9 reactions, the Big Bang of planets. Why do quarks have such destructive power? Because the universe is made like a game of Russian dolls. What we see, the external cover, is mostly a bubble of empty space. But the last tiny Russian doll, which is made of quarks, occupies the nuclei of our atoms and is pure, solid matter. According to Einstein's equivalence between energy and mass, quarks contain 99% of the mass energy on planet Earth. If all the planetary quarks were to transform their 99% of mass into pure energy, it would lead to a Big Bang explosion equivalent to the most powerful explosions in the known universe.
Gravity is the dominant force in the universe. This tenet of Einstein's was irrefutable.
In 1939, Einstein discussed what would happen when a large amount of matter was concentrated in a small region.
Einstein wondered, could its gravitational collapse crush its vast quantities of matter into the tiniest of points?
In early 1964, Gell-Mann proposes to the world the existence of three new fundamental entities he calls quarks. They're more like little planetary systems. All the positive charge and virtually all the mass is concentrated in a tiny nucleus.
Now, what are the quarks? Are they actually real objects? Well, my experimental friends are making a search for them in all sorts of places. One atomic spectroscopist friend of mine calls me up sometimes at midnight to report his progress in a search for quarks in seawater. Most things with curious chemical behavior in the ocean end up eaten by oysters. And so now he's grinding up oysters and looking for the atomic levels in the oysters. So far, though, no quarks.
His three quarks could combine in different ways to reproduce the properties of this enormous particle zoo. It would simplify, organize, predict. It was a great scientific advance.
When Murray Gell-Mann's three hypothesized quarks were finally found, humans learned that they were made of the two lightest ones, the up and down quark, which combine in triads to form the protons and neutrons that make up all the atomic nuclei of our planet.
If the outer boundary of a hydrogen atom, where the electron is found, were enlarged to be 2 miles wide, about the size of a city, the single proton in its nucleus would be the size of a golf ball. It's here we find elements at their most elemental, because every nucleus contains protons, and it's the number of protons that determines what kind of element the atom is. The number of protons is called the atomic number, and it's the fundamental organizing principle of every table of the elements.
All the other heavier particles in the universe contain the third strange quark, which has 15 times more mass energy than the sum of our lighter up and down quarks. Strange quarks do not exist naturally on this planet, but account for the ultra-dense core of pulsars and the dark, ultra-heavy matter of the galactic halo. It is precisely this third massive strange quark that Brookhaven's particle accelerator is now producing in huge quantities in its collisions. When the cover of atomic nuclei are broken in these collisions, strange quarks are liberated and form a liquid explosive that is boosted by their large energy mass. This formation of strange quarks is called a strangelet and has an enormous attractive power. To put into perspective its huge mass energy, a single spoon of strangelet weighs 1 billion tons. That is 3 times the mass of the entire human population. A strangelet's gargantuan attractive power could suck in an entire planetary mass within a few days. Physicist Franz Wilczek called the explosive conversion of ordinary quark matter into a strangelet an Ice-9 extinction. The term Ice-9 was borrowed from Kurt Vonnegut's satirical book Cat's Cradle, in which an American physicist discovers a similar strange liquid that freezes the planet into ice and extinguishes all planetary life. In the words of Vonnegut's masterpiece, "When I was a much younger man, I began to collect material for a book to be called The Day the World Ended. The book was to be factual. The book was to be an account of what important Americans had done."
In theory, strangelets have the power to devour the Earth. Millions of times heavier than gold, they have a gravitational force so great that nothing can resist it.
Everything that strangelet touches changes into a strangelet. So if you make one in a room, for example, then all the atoms in the room will start falling inwards towards the strangelet, and the strangelet will suck in that matter and grow and get bigger and bigger.
They have finally done it. Brookhaven's collider is now distilling strange liquid explosive, a substance that all the nuclear industry safety reports considered impossible to manufacture on planet Earth. Or, as Frank Wilczek, one of the authors of these safety reports, explains quite cynically, there are no safety measures that could contain an Ice-9 extinction.
I've never been so confident, though, of making a prediction as when I was called to sit on a panel about the possibility of an accelerator turning on and ending the world. Predicting that it won't is very safe, because if your prediction is wrong...
So physicists will go ahead with those experiments, playing a cosmic game of Russian roulette with us all. One might wonder how scientific experiments that seem more like the suicidal actions of a terrorist can be taking place in a country like America, known for its war on terror and paranoia for safety measures. Why would nuclear physicists, a group of seemingly normal human beings, backed by all the resources of our society and with the support of our governments, the hype of the press, and the applause of the entire population, move forward with experiments that pose such a clear risk to our lives? The answer is surprisingly simple. We belong to an industrial culture that idolizes the machine as the supreme expression of power and knowledge. In the words of Erich Fromm, a technological civilization is programmed by the principle that something ought to be done if it is technologically possible. If it is possible to make nuclear weapons, they must be built even if they destroy us all. Once this principle is accepted, humanist values are dethroned, and the evolution of the machine becomes the foundation of ethics. So instead of advancing human needs as an ethical society would do, a technological civilization caters first to the needs of machines. And as with any other religion, the technological civilization and its idol, the machine, cannot be questioned or placed into doubt, regardless of the collateral damages it might cause to its human worshippers. In the sacred name of science, believers in technology seem willing to accept risks as necessary sacrifices to achieve the holy grail of future progress. In light of such a collective, fanatic frame of mind, what the news from Brookhaven's collider really means for mankind is that as of the 21st century, the nuclear industry has reached such technological power and efficiency that it can destroy us all, not only with its primary product, the bomb, but also with its particle accelerators. An ice-9 reaction requires only a microscopic critical mass of strange liquid to explode the Earth, and that critical mass is within the reach of our Big Bang machines. Strangelets will be created because they represent a technological achievement. The notion that these industries will create any machine simply because it is technologically feasible is difficult to express to most people because we naturally want to believe that our taxes are being used to develop life-enhancing sciences that will benefit mankind. But the nuclear industry has survived every attempt to dismantle it by disguising its negative effects on mankind with a shrewd marketing strategy. On the one hand, it highlights the imaginary benefits of those particle colliders for mankind so that governments will pay for them.
The science world is buzzing about what could be a major discovery.
Particle known as the God particle.
God particle.
It may mean we'd be able to unlock limitless energy. Let me just put it that way. It may be that we would understand the next secret of the universe.
The result of this dual cover-up strategy is a surrealist scenario in which, outside of professional papers, nuclear physicists do not discuss what they primarily produce in their atomic collisions, which is 99% strange liquid, since that is a threat to minimize. Meanwhile, the press, which obeys the same ethics as a technological civilization, disseminates with preposterous hype a litany of impossible theories and magical particles that will supposedly open the doors to heavenly knowledge.
We may discover additional space dimension, the mystery and the origin of the universe.
We may be at the end of the road.
The entire control room is like a group of 6-year-olds whose birthday is next week.
It's incredible that it's happened in my lifetime.
Whatever we learn is going to have a dramatic impact on the way human beings think about the universe forever.
On the other hand, in its cynical safety reports, the industry minimizes the danger that the production of strange liquid poses to human life.
There is no chance that the LHC presents any danger to the world. It's complete internet nonsense. There's a tiny, minute chance, which would be exciting actually, that you can create these mini black holes.
I have a sort of 0.01% worry that they'll create a real black hole and the entire Earth will disappear in a nanosecond.
A few scientists have warned mankind of the risks of extinction inherent to those quark explosions, both in scientific magazines and through litigation in American and European courts. Frank Wilczek, an expert in the strong force that glues quarks together, warned that the new energy regimes obtained in Brookhaven's relativistic heavy ion collider could create strangelets. Otto Rossler, one of the founders of chaos theory, and Walter Wagner, a safety officer of accelerators at Livermore, the birthplace of the industry, cautioned on the risks of creating black holes.
The main problem which I'm working on for the last 3 years, which is whether a certain experiment which is being done on our planet is not at variance with the ideology and hope for sustainability. Because science sometimes is dangerous to sustainability. The experiment on little black holes that they are doing is so dangerous.
Given these clear and present dangers, Walter Wagner, following his duty as a safety officer, repeatedly sued the industry for potential genocide, asking for an injunction to prevent any further upgrades to those machines.
What happened?
People for RHIC submitted a sworn affidavit from one physicist who simply had conclusionary language saying it was safe without any demonstrated proof, but it was presented by a government attorney, and the judge sided with the government attorney and dismissed the case.
As the news of this new doomsday weapon spread globally, the nuclear industry was forced to create its first safety report in 70 years, which was commissioned to the very same Wilczek that had denounced the risks of creating strangelets and an ice nine extinction.
You've read that there are theoretical speculations that at the next generation of high-energy accelerators, one might produce small black holes. And that's true. Otherwise, respectable physicists have suggested that kind of thing. Nature is so inventive and malicious that it's a logical possibility. It's always a logical possibility when you do something that's never been done before that'll lead to a catastrophe. Just to conclude, I've never been so confident, though, of making a prediction as when I was called to sit on a panel about the possibility of an accelerator turning on and ending the world. Predicting that it won't is very safe, because if your prediction is wrong...
Wilczek accepted the ethics of a technological civilization, and his cynical retraction and betrayal of truth paid off. The nuclear industry was pleased, and he went on to win the Nobel Prize for Physics a few years later.
And Frank Wilczek.
A destiny that contrasted sharply with that of Dr. Wagner, who was submitted to a massive ad hominem campaign by the public relations arm of the industry. The mainstream media simultaneously ridiculed Dr. Wagner with the comical newspeak of, "Don't worry, be happy. The apocalypse will not be today."
I headed to the Doomsday Machine's home base, just outside of Geneva, Switzerland. This begs the question, why the would you recreate the Big Bang? Does that not sound a bit dangerous? I sat down with pioneer particle physicist and experiment leader Dr. John Ellis.
Why do you want to destroy the Earth?
We don't, and we won't.
And suddenly, there it was, the collider itself. Clearly, these scientists were up to no good. There was shiny machinery I didn't recognize everywhere I looked. How safe is this place?
This place is perfectly safe.
Then why are we wearing hard hats?
It is safe for safety. You're wearing safety helmets.
Checkmate.
Nobody with any expertise in physics or astronomy or astrophysics thinks there's the slightest risk of any danger whatsoever.
Oh, really? What about this guy?
When we slam two atoms together, some theories suggest they might collapse into a micro black hole, and eventually it would convert the Earth into a black hole.
That's Walter Wagner, the one man with the courage to speak out against the experiment.
Walter Wagner is haunted by visions of apocalypse.
This experiment could create a black hole.
According to Walter L. Wagner,
might even create a black hole.
It could end up destroying the world.
But don't worry, Wagner has a plan.
I filed a lawsuit in the Honolulu court system.
Ultimately, all lawsuits against those particle accelerators were dismissed on legal technicalities because CERN has the diplomatic immunity reserved for other city-states, like Vatican City, the City of London, and Washington, D.C. This legal city-state status denies courts any right to regulate or even question the activities of these nuclear, religious, financial, and military powerhouses. When the lawsuits were dismissed and all hurdles overcome, CERN threw an end-of-the-world party to celebrate.
It looks like a Mayan inscription to the Mayan Commission for Human Rights.
Wait a minute. I think I can make out the names of the authors, look. It's Walter Wagner and his friend Otto Rüssler.
What? Already in 1009? They've been persecuting us for 1,000 years already? The brain collision will be caused by a particle accelerator near Geneva.
They say it might destroy the planet, or it might not.
CERN finally turned on its epic machine in 2007 and fired its first atomic shots, but the collider broke during the trial period.
An enormous blast destroys hundreds of the superconducting magnets that shoot protons through the accelerator.
Since the accident, it has been running for 7 years at half its potency and will only have a chance to produce those black holes in the year 2015, after 2 years of extensive upgrades that have doubled its energy potency to 13 teravolts. Astonishingly, What was kept from the public while everyone had a big laugh at Walter Wagner and Otto Rossler is the little discussed fact that the 4 safety arguments provided by the nuclear industry in their never updated 1999 safety report were all false. Let us consider them in detail, since our destiny might depend on them. The first assurance, repeated ad nauseum in all the industry's reports and media appearances, is a deceptively simple lie, which, like the Higgs hype, relies on people's ignorance about physics.
Dr. Ellis seemed all too eager to explain away the dangers of his experiment.
The universe has been bombarding the Earth, the Sun, and the stars with cosmic rays which have much higher energies than the collisions we're going to make with the LHC.
Oh, yeah?
It is true that cosmic rays travel through the cosmos, collide with stars and planets, and the galaxy still exists. But that has nothing to do with the risks associated when quark explosions convert matter into a strangelet. Why? Because cosmic rays are not quarks. They are an entirely different substance. 99% are gamma rays and protons, while the remaining 1% are atomic nuclei.
And his identity? Naked atom.
The late Enrico Fermi, one of the great pioneers of modern science. Fermi suggested that within our Milky Way, gargantuan badminton games go on, in which the players are these huge magnetic fields, and the birds are tiny naked atoms which have been shot into space from erupting stars. And the atoms are naked because the star heat is so intense that atoms can't hang on to their satellite electrons as they do at normal temperatures.
What
When such an atom is exploded into space from a star, it will eventually collide with a magnetic field and bounce off.
Those lonely cosmic rays are coming from faraway stars, and they arrive and collide with planetary bodies in solitary, harmless units. They are not masses of heavy gold and lead atoms, with hundreds of quarks packed in tight bundles and cracked in precise collisions that liberate a critical mass of millions of strange quarks that are theoretically capable of starting an Ice-9 reaction. The fact is that we have never found a single deconfined quark in a century of cosmic ray analysis. The industry's first safety argument is therefore a blatant lie that breaks 2 fundamental scientific proofs of truth: experimental evidence and the known cause principle. The primary reason physicists are doing those experiments in particle accelerators is precisely because nature does not do them on planet Earth. Otherwise, we would just keep building cosmic ray detectors like the one CERN has in its museum, which reveals precisely how unimpressive the force of a lonely cosmic ray actually is. The second safety assurance refers to baby black holes, which will be theoretically possible to form in 2015, when the Large Hadron Collider doubles the potency of its collisions.
I heard some questions that maybe the next generation of particle colliders would create conditions in which you might
create what?
Create high enough energy conditions that for some reason a tiny black hole might spontaneously be created, which could be very dangerous.
There are 2 questions there. So the first question was, or statement was, that you've read that there are theoretical speculations that at the next generation of high energy accelerators, one might produce small black holes. And that's true. Otherwise, respectable physicists have suggested that kind of thing.
It is important to note that the creation of black holes at CERN is considered probable at those new energy regimes by both promoters and opponents of these colliders.
Many black holes could be created by smashing a proton into an antiproton with enough energy. If one were created near a large concentration of mass, And if it started absorbing that mass before exploding, the black hole could reach a relatively stable half-life and thus continue to grow.
In Einstein's classic theory, black holes are frozen stars that are likely composed of the heaviest top quarks, which will be mass-produced as the primary decay particles of the Higgs boson. Modern string theory also predicts that black holes will be created at these new energy regimes. But according to relativity theory, once formed, these black holes will swallow the Earth and kill us all. Since the industry of accelerators knows it cannot deny the possibility of creating black holes, it has chosen to simply rebuke those risks of extinction by invoking a false safety assurance about the nature of black holes. Their claim is that these black holes will simply evaporate, which is based on an unproven hypothesis that contradicts both Einstein's black hole theory and the fundamental laws of thermodynamics.
He coined the word entropy to mean the amount of thermal energy not available to do work. Based on the everyday observation that warm objects such as a cup of coffee always spontaneously become colder, Clausius stated the second law of thermodynamics, that the ability of energy to do work is always decreasing. In other words, the universe tends towards maximum entropy.
According to Einstein's equations, a black hole is born as a mass vortex that turns at light speed. This means that in terms of temperature, it is extremely hot. The black hole then begins to grow its mass exponentially as it lowers its temperature, transferring its extreme heat to the star or planet and devouring it in a dual Big Bang, Big Crunch. According to the laws of thermodynamics, heat always moves from the hot source, in this case the black hole, to the cold environment it evaporates, which would be the Earth. Yet to eliminate the risks posed by black holes, the safety report denies both the sacred laws of thermodynamics and standard black hole theory, choosing instead to believe Stephen Hawking's never-proven hypothesis that black holes break all the laws of thermodynamics and evaporate.
That is a great story.
Quite amusing, Dr. Hawking.
Einstein is laughing because Mr. Hawking's evaporating black holes break most of the known laws of science, which according to the scientific principle of correspondence is a proof of falsity. Evaporating black holes have also been disproven experimentally after 30 years of unsuccessful searches for them in the cosmos, which is another basic proof of falsity.
My supervisor, Dennis Sharma.
The artist Escher called impossible objects, where you can design an object on a piece of paper, and Escher made such designs, which can't be realized in the real world. For instance, there's a picture where the steps go round in a circuit, but they're always going down as you keep going round. You then end up where you began, and yet you've been going down all the way. And you can draw something which suggests that, but in fact you couldn't construct it in the real world, and had the kind of mind that would conceive relationships of that sort.
But of course, once you break the fundamental laws of science, all kinds of magical possibilities present themselves. Hawking, for example, advertises his imaginary black holes in conferences around the world as a potential source of perpetual energy, the most common hoax of 19th century science, before the laws of entropy made them impossible, a fact that Mr. Hawking seems to have forgotten.
Some of the collisions might create micro black holes. These would radiate particles in a pattern that would be easy to recognize. Nothing could get out of a black hole. But I discovered that particles can leap out of a black hole. Its speed, therefore, will be rather uncertain, and can be more than the speed of light, which would allow the particle to escape from the black hole.
Sir, I have a plan.
A black hole of the mass of a mountain would give off X-rays and gamma rays at a rate of about 10 million megawatts, enough to power the world's electricity supply. harness a mini black hole. You couldn't keep it in a power station because it would drop through the floor and end up at the center of the Earth. Gravity will pull harder on your feet and your head because they are near the black hole. The result is you will be stretched out longwise and squashed in sideways. You would be torn apart and made into spaghetti before you reached the horizon. About the only way would be to have the black hole in orbit around the Earth.
Nuclear reactors could provide power almost indefinitely. Greenhouses could maintain plant life.
People have searched for many black holes of this mass, but have so far not found any. This is a pity, because if they had, I would have got a Nobel Prize. It might be possible to observe this at the LHC, the Large Hadron Collider, at CERN in Switzerland. So, I might get a Nobel Prize after all.
If you take the Earth, to give you an example, and you take a vise, if you could make a vise and you squeeze the Earth has a radius of 6,400 kilometers. If you could make the radius 3 centimeters, the Earth would become a black hole. 3 centimeters, this big. Then it would automatically further collapse onto itself. Nothing could stop it, and it would become a black hole. And you could never, light could never leave it, radio waves could not leave it, because they all go with the speed of light.
After 5 years, the Earth will be shrunk to 2 centimeters, which is the opposite of sustainability.
But CERN and Mr. Hawking may yet lose this insane race for extinction to Brookhaven's Heavy Ion Collider, since they have already admitted to producing strange quark liquid. This fact alone disproves by sheer experimental evidence the third safety assurance in their 2-decade-old report, which claims that strange quark liquid will not be produced on planet Earth because it is in fact a hot gas, not a liquid.
It expected to find a gas with little or no interaction among quarks and more uniform expansion. Instead, the asymmetric expansion and strong interactions have led RHIC researchers to conclude that the early universe was a nearly perfect liquid.
In a surreal twist, while new scientific papers appear constantly on the physics of the strange liquid being produced in those accelerators, the world is assured that such a feat is impossible. Similarly, CERN installed the Castor detector, a calorimeter that will search for different types of strangelets with a stated 70% chance of finding them. Yet officially, there is no danger because there will not be absolute proof of an ice-9 reaction as long as the Earth continues to exist. Despite these dangers, a second process of liquid formation, the creation of stable, dual strange quark atoms, called dibaryons, has begun in both the colliders at Brookhaven and CERN. The creation of a strangelet mass large enough to start an ice-9 reaction is consequently almost certain. Invisible dual strange atoms, more stable than our matter and so heavy that when created, immediately fall towards the center of the Earth, cutting through the light magma like a knife in water. They are sitting there as we speak, growing in numbers until they reach the supercritical mass needed to freeze the planet. Only then will we have the absolute proof that the Earth no longer exists. As Dr. Alnak from CERN's Large Hadron Collider explained, we know no absolute barrier to the rapid growth of a dangerous strangelet. In a catastrophic chain reaction, the weight of a killer strangelet would pull it down. Eventually, the strangelet would sit at the center of the Earth, eating other nuclei, attracting the Earth's mass gravitationally. It would eat our planet from the inside out, converting the Earth into one giant strangelet and killing us all in the process. Since we cannot observe the center of the Earth, there will never be an absolute proof of this slow leak of strange atoms, just like there is no absolute proof of the more than 200,000 victims of Chernobyl or the statistical spike in thyroidal cancer among Fukushima children.
だから作られる甲状腺は補正要素が作られてるから、だから生まれた時から先天性の甲状腺が乗った形で生まれてるの。
それもね、チェルノブイリなんかでもいっぺん降ったんじゃなくて、地球の中もぐるぐる回るから何回も降ってるっていうね。死亡するまでは最初の突然変異が起こってから僕たちの常識では15年ぐらいが必要なんですね。だからところが昭和じゃない1986年ここでチェルノブイリがあるんですね。
そうですね。
でこれからちょうど10年なんです。で10年ではちょっと短いかなっていう感じがするんですけど、これだけまとまって東北北海道それから日本海に来るにはチェルノブイリしか考えられないよね。
The nuclear industry simply denies the potential deaths caused by the invisible leaks of their radioactive atoms. Just like the fourth safety argument affirms that 15 years ago, when the report was signed, there was no absolute proof of the existence in nature of the very same strange quark matter its accelerators are producing right now. This lie is falsified by the industry's own experiments and by all the pervading presence of quark matter in the universe. There is now a general agreement among astrophysicists, for example, that the core of pulsars is made of quark matter, which is responsible for the explosion of stars called supernovas. But because quark matter does not interact with light, we cannot see the star's core. Instead, we detect them indirectly through their attractive gravitational pull, which is the same proof we have of many celestial objects comprised of massive quark dark matter. As it stands, the two families of heavy quarks are the only known substance whose invisibility, coldness, and weight correspond to those of the two invisible, massive, dormant cosmological species of the galaxy, black holes and the galactic halo. Strange quark liquid has the same physical properties found in the external halo of dark matter that surrounds and protects galaxies and stores 90% of its mass. Top quark condensates are the only known substance with a similar mass and density to the swarms of black holes found in the center of the galaxy. In between the two, we find the third light family of up and down quarks that form the visible matter of stars and planets that make up our world. Furthermore, we know that our light matter is constantly devoured and converted into quark stars and black holes. This process continues until a galaxy is entirely made of dark matter and becomes invisible, creating a gravitational pull that is so great that it bends even the path of light. This beautiful symmetry between the three main types of cosmic bodies in the galaxy and the three families of quarks proves that quark matter not only exists, but is the main component of all the galaxies that form our universe. So yes, we are still here, but our likely destiny is to become the cosmological dust of quark matter. And all those accelerators are doing is to accelerate our demise by creating the strange quark liquid that is responsible for most of the catastrophic explosions taking place within the different scales of the cosmos. Despite all these facts, for the accelerator industry, it is business as usual, with plans for even bigger accelerators like the Chinese Super Collider that will host a city of physicists within its 80-kilometer circular perimeter. Also in development are cheaper and more powerful varieties of plasma accelerators that will ramp up quark production and secure our destiny as a species that becomes a strangelet floating in the galactic halo. Is this the meaning of it all? Are we so insignificant to the universe? But such a destiny, measured by human time cycles, would take millions of years if we had the audacity to stop the evolution of weapons and adopt the ethics of a humane civilization. This choice is perfectly illustrated in the so-called Fermi paradox that still puzzles scientists to this day. Why? In a universe teeming with inhabitable planets, is there no intelligent life communicating or traveling through space?
Launched in 2009, this incredible optical telescope has revealed that planets are far more common than we ever imagined.
What's amazing is not just the number of planets that Kepler has found, but the types of planets.
Of the 3,500 potential planets that Kepler has spotted, some seem familiar. Huge gas giants, similar to Jupiter or Saturn. Or smaller rocky worlds that could be like Earth, Venus, Mars, or Mercury.
People have suggested that there might be 10 to the 19th planets in our galaxy or in nearby galaxies. That's a very big number.
It's this emerging statistical fact that leads many scientists to be confident that extraterrestrial life does exist.
If extraterrestrial life is so probable, what silences them? The Fermi paradox has only two scientific solutions outside the field of religion. The technological solution is clear. Any planet that evolves technologically is destroyed before it reaches interstellar travel by the nuclear industry, either through nuclear warfare or the conversion of the planet into dark matter. Weapons evolve faster than all other fruits from the tree of science. Since scientists consider interstellar travel within a century's reach, it seems highly likely that the nuclear industry will destroy the Earth within decades. This has unfolded in the same manner on every planet where animal life follows the ethics of a technological civilization. Otherwise, our galaxy would have already been colonized by a technological civilization. But the universe is just, and so for those planets that respect life more than technology, the Fermi paradox also has a humanist solution. On those planets of flesh, truly intelligent life does not construct nuclear weapons. They do not communicate with the galaxy, colonize other planets, or care about technology. They are paradises of life, art, and human senses, forever happy, immortal, and sustainable.
I once wrote a paper with this title, Sustainability of Humanity. Immortality, in one word. So, responsibility would be another word. And hope, a third.